Alright, so we're going to look at solving systems of equations in ways other than graphing. And so these are going to be more algebraic methods, so that we don't have to rely on accurate graphs to solve. And so there's two methods we're going to look at in this class. The first one in section 11.2 is called substitution, and then in 11.3 we'll look at a method called addition. So the main idea is this. In the previous video, previous section, we looked at systems. We had a system here where the two graphs intersected at one point. Well, anytime you have two graphs that intersect, at that point the x values for each equation and the y values for each equation are equal. At every other point, the y values will be different for the same x value, but at that point, the same x value gives you the same y value. And so if x's are equal and y's are equal, they can be substituted in for each other. Okay, you can always substitute in equations things that are equal to other things. And so that's the theory behind what we're doing here. So let me show you an example of how that works. I'll even look at that same system of equations that we looked at in the last video. So we have y equals x plus 1 and y equals negative x plus 3. Now, because the y values are the same at that intersection point and the x values are the same at that intersection point, we can do a substitution. Anything that is equal to y can be substituted for y in the other equation. Okay, so what we're going to do is we're going to take this expression and replace y with it in the other equation. And so on the left here, this y becomes x plus 1, and that's going to be equal to negative x plus 3. So you can see how this y turned into the x plus 1, the negative x plus 3 stays, and then we solve the equation, solve for x. So I'm going to add an x to both sides to zero it out from the right. That gives me 2x plus 1 equals 3. Then I'm going to subtract a 1 from both sides to zero it out on the left. That gives me 2x equals 2. And then I'm going to divide by 2 on both sides to cancel it out on the left again. And that will give me an x value of 1. Now remember, a solution to a system is an ordered pair. Okay, you need both the x and the y value. And so if this is the x value, I can use it to find the y value simply by plugging it in to either of the original equations. Now I'm going to plug it into the first equation. Y equals, this x will become a 1 from that one, and then a plus 1, okay, which is obviously 2. Now if you think about it, it doesn't matter which equation you substitute it in for. If I take the 1 and plug it in for this x, you'd have negative 1 plus 3, which also is equal to 2. So it won't matter which one you use. They should always give you the same result, as long as you solved correctly the first time. Now that I have the 1 and the 2, my final answer, my final solution is the ordered pair 1, 2. And if we look back at the example we saw earlier, that was the point of intersection for the graphs. Okay, so that really does work to use a substitution like this. Okay, so there are, I would say, 5 steps, I think, for solving a system in this way. And I'll jot the steps down just so you can follow along here. So step number 1 is to solve for a variable. Now in this one, the variable was already solved for. We already had y by itself, but sometimes that's not the case and you've got to get a variable by itself. Now it doesn't matter which variable and it doesn't matter which equation. So we're going to say either variable in either equation. Generally speaking, if you can find a variable whose coefficient is 1, that'll be the easiest one to solve for. I'll explain that in the next couple examples. Number 2 is you then substitute the resulting expression into the other equation. Okay, so that's what we did here in the blue marker. We took the x plus 1, that's the resulting expression, and we substituted it into the other equation for the y. Okay, step 3 is to solve for the remaining variable. Okay, and of course, once we did that substitution, the remaining variable was x, so it eliminated the y as a variable. We solved for it and got a 1. Okay, step 4 would be to substitute the value into either original equation oops, you can't see that, to find the other variable. Alright, so that's where we took the 1, substituted it into either of the original equations. Remember, I said it didn't matter which one, and that allowed us to solve for the variable. It's for the other variable. And then number 5, the last step, is to write the ordered pair. Okay, and that is very important. You must have the ordered pair as your solution. Okay, in the next video we'll look at a few other examples, more difficult ones, and a variety of different conclusions.